Good morning, students. Today we are continuing the molecularity of the reactions and especially for the complex reactions. So, when the reaction is a simple reaction, that time the molecularity can be determined, right, by the single step or the simple reaction. But when it is a complex reaction, right, that time the molecularity, right, as well as the order of the reaction, right, it is not going to depend upon the single reaction. It will depend upon the steps of the reaction, right. So for the molecularity of the reaction, we can determine the molecularity of a simple reaction, right. But for the complex reaction, it is not possible to determine the molecularity of the reaction, right. So in that case, we have to just get the complex reaction written down in term of the steps, right, and that will become the mechanism of that complex reaction, right, students. So let us take an example here of formation of NO2F, right. When the NO2 plus F2, that is nitrogen dioxide and fluorine molecule, they reacts, right, then the formation of NO2F takes place. Now here in this, right, this is the appears to be a simple reaction, right, but it takes place in the step, right. So the first step that will be, it is NO2 plus F2 gives NO2F plus F, right. Student, this is the slow reaction, right. Then the second step will be NO2 plus F, right. It will give NO2F, and this is going to be the fast one, fast reaction, right, or fast step. Now when we just add up this equation, right, so first of all this fluorine to fluorine will get cancelled up. So here how many molecules of NO2 are there on the left hand side? It is 2 NO2, right, student. So here we have got plus F2, and we will get 2 molecules of NO2F. Now this is the overall reaction. So students, here we have got 2 molecules of nitrogen. This side also fluorine is also balanced. So the net, we can write it in this way, right? Now here students, we have to, I'm going to add few terms, right? This is a complex reaction. So it will take place not only not by the collision of the 2 molecules of nitrogen pentoxide, nitrogen dioxide with 1 molecule of fluorine, right? This reaction will not take place just by the collision of the 2 nitrogen dioxide molecule with 1 molecule of fluorine, right? It is going to take place in step. First, 1 nitrogen oxide molecule will react or will collide with fluorine molecule, right, to form NO2F and F, and then NO2 molecule will combine or collide with this F molecule, right? So the complex reaction takes place in the steps, simple steps. Now the each step, right, the each step will be known as the elementary reaction. Yes, students. So what is an elementary reaction? Elementary reaction is a simple reaction, right? Or we can say it is a reaction, right? Or it is a reaction, a single reaction of a complex reaction, right? Now, second thing comes that what is the role of writing, or what is significance of writing slow reaction and fast reaction? Now, students, the slow reaction is always the rate determining step or reaction, right? Again, I am repeating, the slowest reaction, right, will be the rate determining step, right? As the it is just similar to that fact that the if we are playing a game, right, the one which will be the slowest one in its act, right? The whole performance or whole rate or the speed of the game completion will depend upon the slowest person, or the we can say the slow performance, right? So here the rate of the reaction is going to depend upon this slowest reaction. Now what, how it will affect now? Now rate means here when we are writing the rate, R equals to, right? Now we are writing in terms of the reactants, right? It will become then K equals to, I have written minus here, it is K equals R minus dx upon dt equals to K NO2 and F2. So in the rate determining step, the reactant involves are NO2 and F2, right? So the rate law will be, right? So rate law is the experimentally determined. So rate law is going to be K within square bracket NO2 and F2. So student, from here you can easily find out the order of the reaction. It will become 1 plus 1 equals to 2, right? So in this way, a reaction which seems to be a simple one, right? But the factor is that sometimes it is possible that collision becomes effective, but sometimes what happens, the simultaneous collision is not possible, right? So that time the reaction is going to take place in the step, right? So in this way, one molecule of NO2 reacting with one molecule of F2 colliding with, right? And the reaction proceeds, right? And each single step of the complex reaction will be known as the elementary reaction, right? So here we can take another example also, right? This was the first example. Now we can take another example where we are taking the decomposition of N2O5, that is nitrogen pentoxide, right? It will give NO2 plus O2, right? So here it is N2, so we are putting here 2 NO2. So in that case, right, so we are having how many molecule here? It is N2O5. So either you can put here half here, okay? Now this we will do later on when we just get it completed, or if you do in this way, so it will be, if you are getting it in this way, so we are having it in this way. So it is 2 N2O5 gives 4 NO2 plus O2, right? Now if this we take this reaction, so the steps involved are that first step, nitrogen pentoxide, it just decompose, right, to give NO2 plus NO3. Now the second step, this N2O5 plus NO3 will give NO2 plus O2, right students? So it is giving us, so we are putting here 2, this is there, either you can put here 2, right? This we will do, this is there, N2O5 plus NO3 gives NO2 plus O2, right? Now here this equation is balanced, N2 oxygen 5, 2 plus 3 5. Now we have to balance this equation. It is N2 5 plus NO3 gives NO2 plus O2. So students, when you balance it, so how it will be going? This one, this is oxygen 5 at 5. We are not going to disturb this, right? This is there, this is there. So we are getting 2 to 4, here also 4 oxygen 10, here 8 plus 2 10. Right, this is there 2 5 10, but this is present here, this is NO3, right? So how we will just get this 3 part added up? Just try to balance this reaction, right students? So until and unless you get the equation balanced up, right, so cancelling will be easier, or it will get easy when we just get the two equation, the simple equations balanced. So just try to balance the equation. So here we have got N2, this is on the left hand side, N2 plus 1, 3 we are getting. So we will put here 3. So in this way we are getting 3 to 6, 7, 8. So it's 5, this is 3, this is getting 8. So students, now this NO3 with NO3 will get cancelled out. We will get 2N2O5 gives, right, 3 plus 1, 4NO2 plus O2. Right, this is there, 2N2O5 gives 4NO2, right, 4NO2 plus O2. Now student, in this reaction, right, this each step is a elementary reaction, right, and here the first step is the slowest step and it is termed as the rate determining step. This is the fast step and this is the slowest step, and this is going to be the rate determining step, right. So if we just see this reaction here, right, the starting one, so here the order of the reaction, right, until unless we have just got this mechanism, you will see the order is getting 2, right, and as well as the molecularity is also getting 2. But when we write down the mechanism and then we just determine the rate of the reaction. So here students, you can see that the rate of the reaction is going to depend upon, in the slowest step, only upon the molar concentration of nitrogen pentoxide, and its concentration term is raised to the power 1. So here the order of the reaction comes to be 1 here, right. So by writing down the mechanism, right, it helps us to write down the rate law, and from there we can determine the order of the reaction. So student, just go through it. Now after this you can find out the difference between the molecularity and the order of the reaction, right. So what is the molecularity? We can say it is a number of the reacting species, right, that is involved, right, in the chemical reaction, the simple chemical reaction, or we can say that the number of the reacting species colliding simultaneously to give the product, right, or to carry out the reaction. Whereas in an order, it is the sum of the concentration, power of the sum of the concentration terms to which the reactant terms are raised in the rate law. Now the molecularity, right, it can't be 0. It is not possible that there is no molecules colliding or there is no molecule involved in the reaction. So molecularity cannot be 0, it cannot be fractional. Whereas the order of the reaction can have a 0 or it can be fractional also, right? So here the other differences, just try to point out, right, the difference between the molecularity and the order of the reaction.